Greetings and welcome to the second video of chapter 10 we are on now. Last video we talked about finding the area of triangles. Today we're going to be talking about finding the area of parallelograms. So quick recap, when we were finding area of triangles, we used the formulas 1/2 base times height or base times height divided by 2. And that was where the base was one of our sides and then the height was that distance perpendicular. So when we're looking at finding the area of parallelograms, we're going to follow the same format to that video. Let's look at some other strategies on how we can find it, and then if we can come up with a formula for the area of a parallelogram based on that. So in this first parallelogram here, we have PQRS, and it looks like this has a side length of PQ being 13, S to T, I'm noticing is perpendicular. So that makes me think that this is the height of this parallelogram. And then because the height is always perpendicular to the base, in triangles at least, that would make me think this is probably the base. So we have some interesting information here. And we know parallelograms, because they're parallel, this other side is 21 here, and this side is 13 centimeters there. But if we're going to find the area of this, I notice that if we take this section here and we flip it over, it will fit into that area there. And so now we have a rectangle that has a side length here of 21. So we can find the area of a rectangle using length times width. So we could use 21 times, let's see, the height, because our new shape is going to be this, of 12. So 21 times 12 will get us the area of that rectangle, which also seems to be the same area as that parallelogram. So this, let's see, 1D times 12 is 240, plus 1 times 12 is 12. So the area is 252 square centimeters, according to this. So because we took that chunk here and we added it in right there, we just kind of rotate it, split it over, it looks to me like the area of this parallelogram is also going to be 252. Which is interesting. I'm feeling less than certain about this, but let's see if there's a way that we can use our knowledge of triangles to help us out. So if we take this parallelogram and we chop it into two separate triangles like that, we know that we can find the area of triangles by doing base times height. So if this is 12 centimeters here, because it's the same height there, parallelograms have parallel lines, we have one triangle that we'll do in blue, and then we have another one that we can do in red. And then we should be able to add those areas together. So in blue, we have a base of 21. So we have 1/2 times and a height of 12. I'm going to put my 12 first because it's even, and that will make it easier for me to multiply. So our area is 6 times 21. Our area is 6 times 20 is 120, plus 6 is 126. For the red triangle, has the same height of 12 and the same base of 21. Oh, interesting. So it's going to be the same 1/2 of 12 times 21, and we just did that math that it's 126. So if we have those two areas, we can add them together, or we could multiply them by 2, because 126 plus 126 is 252, but this is the same as 126 times 2. So we got 252 square centimeters, which is the same thing that we got when we solved it the first time. That's a party. That seems good. But I'm noticing, though, we did this same math here. And then at the end, we ended up multiplying it by 2. So it looks like we did area equals 1/2 times 12 times 21 times 2. And we know back from our days of solving algebraic equations, that 1/2 and the 2 are going to simplify. And so we will just be left with doing 12 times 21, which is exactly what we did up top here. Now, we know that that is going to equal 252 square centimeters. So let's look at what these different numbers meant in the problem. So this 12 is our height. So it seems to reason that the area of a parallelogram is going to be equal to the height times, let's see, this 21 down here is our base. So our area of a parallelogram is equal to base times height. A equals BH. So let's try that one more time on this one. If we start with our formula of area of a parallelogram is base times height. If 21 is our base, our height is 12, because these are perpendicular. So area equals 12 times 21. And so area equals 252 square centimeters. Hey, check it, that works out. So we know this formula is good, so we can add that onto our list of formulas that we know. Let's try one more example and see. If this is our parallelogram, we know area equals base times height. We need things that are perpendicular, and it looks to me like this 13 is perpendicular to the 4. So our 4 must be our base, and our 13 must be our height. So the area of this parallelogram is 4 times 13. So the area is 40 plus 12. The area is 52, and these are square yards. Now we could check this using another strategy, the triangles perhaps, or we could, let's do some triangles. So if we chop this triangle here, it's going to have a base of 4, so the purple one. It's 1/2 times the base, which is 4, times the height, and we know the height is 13. So area equals 2 times 13, area equals 26. And it was going to be the same thing for that orange area. This base is going to be 4, the height is still 13. So we have the same work. We could have just multiplied that by 2. 26 plus 26 is 52. So we know this formula works, and then we can find our area of parallelograms. So crucial to being able to find this formula was our knowledge of area of triangles. So this has been a really useful video. If you haven't watched that one yet, you can go check it out.